building management system. What is building management system? What does a building management system comprises of? So-called comprises of what? And what makes a full system? And how can this system be applied in your daily work? So we need a lot of guests here, the people here are from MEP. So it's good. After that, he will go on to talk about fire alarm system. Okay. So he will teach us when there's a fire, how should we run? First is fire, we run first. Okay, the system put in one side, we run first. So he will teach us how to run and find the nearest escape door to run away. Am I right? To run, right? Not to design a system, but to look for a way to escape. So, okay, I'm not a guest speaker, so I wouldn't want to speak too much. I will leave the floor to Mr. Thai. So please feel free, if at any juncture you have any questions, you can raise your hand. One hand or two hand, no problem. You can even raise your leg if you want and ask him. Because I don't pay for his time here. But nevertheless, even if I don't pay for his time, we will still question him. So we will make sure we ask him a lot of questions until he drops dead. Then this event will be very successful. Okay? If not, then let's put our hands together and welcome Mr. Thai.
With more than a century of building control experience behind us, we are building a world that's safer and more secure, more comfortable and energy efficient, more innovative and productive.
This is a system, the centralized system that can connect all the M&E equipment inside the building together, and the operator can sit in the control room and control everything in the building. So that's what we call building management system. And that's like the latest system nowadays. We have to talk about like open communication system, because in order to integrate, to have all the subsystems that have to talk in the same language. Like nowadays, I think like the open system like BMS or long work or Modbus. This is the open system. Like we speak in the same language and we can understand easily. So communication, the data it work in the same way. So first of all, we have to select the subsystem have to open system that can release the data to the building management system in order for building automation system to integrate everything together in one central control station. BMS is always referable because BMS stands for Building Automation Control Network. So the group of people in the US, X-Ray, I think X-Ray, many manufacturers, they call many manufacturers to sit together and develop the common language. Everyone have to follow it. Because in 20 years ago, everyone have speak different languages. So when you need to integrate together, no way you can do. All you have to pay for the price of the translator, something like that. So very difficult. And also the owner have to tie to one single supplier. In case you want to change something, you have to call this guy. Whatever right they charge, you have no choice because this is not open. So now they come up with the standard open protocol for BMS. So everyone, if you want to go in my project, you must sure you have that protocol. And then the BMS guy don't just a minimum charge, okay, this need the point list. Okay, just make the point. Very easy. Yeah. And then of course some power meter, because the power meter with a small processor and they don't produce BMS, so they go with Modbus. Also can be done. So the Modbus, because this is also standard, so many people they have already have the translator to translate the stream Modbus to BMS. Actually, BMS is defined by X-Ray in US, and if you want to products is certified by BMS, you have to see the tick in the BTM laboratory. So if they display they are BMS, but if nobody no property confirm that it's like you say you comply to BMS only, but no certified. So you need to see the tick BTM. Yeah. You want to monitor whether the fan is running. This is the number, and this is the alarm. So this is the four ways that I want to be green building and green mark requirement and leak requirement. And of course, you need to install on-kind meter to make sure that you optimize the usage of electricity bill, water bill, gas, and BTU, everything. Not only on-off, but set more as well. And first step is smart scheduling is shut down unnecessary equipment when not needed. And take control schedule must still be the quickest safe way to ensure investment in the energy bill. So we can have the on-HCAC schedule, monthly schedule, or door access schedule. Door access means some of like per pound you don't want people to enter some logistic grid or something like that. So we have to shut down the door.
So we're talking about the city power fail when you start the generator.
Yeah.
So can the system do in such a way that they are smart enough to build a tenant? Okay, this is city power. I bill you at so much. When you run the generator, then I bill you maybe at a different rate per kilowatt hour.
Oh no, not this way. I said about the loss setting. That means I'm not allowed for the equipment to cut in. Otherwise, you will trip the genset.
So let's say if I have an issue of, let's say, city power fail and I run my generator, so I only have 1 meter. So if I run my generator, essentially the cost belongs to the management, not the city power. But the city power will also bill you for the power supplied by the generator. So do you have a system that is smart enough to say, okay, now it's run by generator, I bill you $1. Run by city power, I bill you 80 cents. If not, the power generation cost from the generator is absorbed by the management. It's not taken away from the city power.
I'm not sure people do like this or not, but if you want to do like that, it's possible with this. Also, you have power meter, right? And you know exactly when the city power is cut off. And at the time that the power is up, we get the data of the power meter, and we just keep track, and we log it. And then at the end of the month, we do the variation, which period is city power, which period is the generator power, and then we just generate. This can be done. Well, I'm not sure whether they want to build like that or not, but with BMS it can be done. Because all the data you log into the system. How like every 1 minute or every 5 minutes you log one value. So you look at the time that the power travel, and you get the information.
But if I'm going to do data logging for every 5 minutes, that means my server has to be very huge.
Yeah.
I need a very big server.
Not that is the data for BMS not very big. I tell you like 10 gigs, maybe like a year or more. So the data is they say in 2 places. One in the controller and another one in the server. So one your server is fails for some reason, your data is still inside the controller. But of course for the software account, like few days until when the power reach the server resume is downloaded to the server. But from the side of the data, not so big. This not an issue.
But you see, when the city power fails, the system will be down. So how do you do data logging? Because you will have a temporary outage of power, maybe for 1 minute or 30 seconds or maybe more.
The main controller always have the UBS, the backup. So that controller used to recognize whether the power fell or not. The chair, at least one controller have to keep the power all the time, either by the battery inside or by the UBS. Yeah. Bacterial mold and virus to make the coil cleaner, so the air more cleaner and energy saving. I think in Vietnam nobody installed that. Not advanced. I don't think it's advanced. Just install next to the cooling coil and to make it clean. This save a lot.
Save what?
Save energy because over time this one will get dirty. The cooling coil get dirty. Either you want to do maintenance very regularly, And this is involved in maintenance cost, right? So you just install the LED light here, and this will clean the coil for you. And this one I tell you before for hotel, the occupancy input. The thing with the eye will see the noise very well. Yeah, just 1 or 2 degree increasing.
But this one you should ask Mr. Sid. He will set this thing. He will decide this.
So this is simple FCU control, and this AHU, this temperature changer, either you put in the room or the return air also okay. Depend on the usage and depend on the design. So basically the send sensor, send signal to controller, and then send back the signal to modulating the valve to just maintain the temperature sample.
I mean, this type of fan coil 2-pipe system is actually many years already.
Just years faster.
Yeah. But for your system, for your BMS system, don't say the brand, for your BMS system, let's say 10 years ago and now, are they a big technology different? Technically, are they a lot different, or just basically the same? Only you change the design. The technology behind are still the same, right?
Now it's first is that because you know the BMS for so long already. So the basis is all the same. The difference is like open protocol. Many people committed to the open system, so you have more things in the BMS. Last time when you want to control something, you just put in your controller, and you cannot touch other people controller. If I want to connect the chiller, I have no way. If I want to get the information from the file system, I have no way. But now everything is possible. So this is different. And the second thing is the web enabled. That means you can access to the system from anywhere in the world with the correct username and password. Your computer, from your handphone, from your any tablet, you can do. And now the database, if you want to save in your server or you put in the cloud, also okay. Because now some manufacturers they want to save the maintenance cost. They don't want to send the people to the job site to do maintenance. Just the data go to cloud and they just sit anywhere and they check whether this building operate the system correctly or not, whether they do is the optimized way, and they do remotely. So many people do maintenance like that. For the building, you can afford to have your full team maintenance, but how about the shop? 7-Eleven or maybe also if you have a control system inside, how to go to maintenance? So they put everything in the cloud and then do it remotely. So that's the difference.
Sorry, can we come back to the FCU singular? The FCU singular, the one you just saw.
Well, the one that I said is many years ago.
Mr. Fu didn't ask you to stop your presentation. Just go.
Sorry.
He's scared of you.
I'm scared of you.
FCU singular.
Which one? This one? This one?
Yes, correct. So in your experience for the FCU, we have the motorized valve there. So usually FCU understand they use just the on-off motorized or modulating motorized we use for AHU or the mid capacity. So in your experience, what kind of capacity range we should use the modulating motorized, and below that, so we should use on and off motorized.
Yeah. This depends how accuracy you want. So the common practice, the PM25 below, you can use on off. But above that, you have to use modulating. And also, the manufacturer side, about 25, they don't manufacture the on off. Wow, they go to modulating. So about 25, modulating, and below, either on off or modulating. Yeah.
So and then the balancing valve there is usually for FCU, we just use the manual balancing valve. The thing is because one of my friends come and introduce us is we can use automatic balancing for FCUs.
Yeah.
And then according to him, by doing that, and we use the modulating motorized by doing that, so we can get more accuracy of the capacity of the efficiency. We can have the benefit there, but we're not sure it's true or not.
Of course, because modulating is more accuracy. Because you can modulate the valve from 0 to 100%. But on-off, you just whether open alone. So you cannot control something in between.
But in terms of, so same like Mr. Ken says, so in terms of cost, and is it efficient for us to invest like that for FCU itself?
Not necessarily. Because most of the case, the valve is not open 100%. So you can go for on-off for the small side. Because even though you have the modulating for small side, the valve still open like nearly 100%. So this doesn't make sense that you have the modulating for such a small side of valve.
So in your experience, I'm not want to impress on that.
Yeah, 25 below or not good enough. Yeah.
Okay.
What's the cost difference between modulating?
The ball.
Double the price.
The ball price in the same side. And not only this, the thermostat is different. The thermostat, modulating thermostat is more advanced than the other thermostat. So they put together, I think, just a lot.
Remember last time TA they come, they introduced the system with automatic balancing modulating for FCU, yeah, combined one. And then they work out the cost comparison. At that time they saw us is so it was enough to invest. So invest in BM25 not work.
When we design a system, we just want don't want to waste the money of the owner. Practical.
So in his opinion, is below 25. Most of the time, maybe is open fully or maybe 80%. So the investment of the modulating, it doesn't make use of it. Maybe when you have bigger one like above 35, then maybe it makes sense.
Yeah.
It's just like small motor DOL. Big motor, you do a variable speed.
That's it, our understanding for a long time. This is the recommendation for me.
And above 25 should not do on up because you cannot control it. The valve serving. So this is silent chiller control. Because we talk about energy saving, so this is the biggest power consumption in the building. So we need to optimize this. So how we control? Only we for the BTU meter, in the number of chiller running, depend on the building lot, we will determine how many chiller need to run. So this is how the BMS do. And nowadays we push on the VSD for every bomb, like primary bomb now, they also have VSD. Condenser water pump also VSD, and cooling tower also VSD. So you know how to control this? Because even you have the VSD for the primary pump, you still have to have the bypass. So what the reason? First, depend on the loss here. When open and close the valve here, the different pressure here will change, right? So when it's like you need to when backlog condition, some of this lows and the different pressure increase, and then you need to reduce the speed of the pump to save energy. But when you reduce it to minimum speed, because you cannot go below that minimum speed, defined by the chiller supplier. For example, 30 hertz. If you go below that, not enough. Chill water flow go to the chiller will trip. So when you go that the minimum speed, but the pressure here is still very high, how do you do? You modulate the open the bypass. And in the condenser not here, but also can have the VSD. So we make sure that we optimize among the flow rate when we do the static conditioning and water balancing.
Any advice on the location, the position of the different pressure sensor? Where
the furthest we have two locations, the furthest one. To make sure that you have enough flow to every AQ you will send have the somewhere here in the center also can, but the set point will be different.
But that's usually done by will be identified by the manufacturer or by the contractor.
By designer.
Design.
Yeah.
The first.
But of course, some recommendation from manufacturer because they are the one who have
It's got
period of that.
Because
Because we have we have a good control, so the manufacturer will.
So because to us the Paris point is not sure is that the point we get the high pressure loss.
No, we just must show that you have enough load to every single equipment in your building. So we find the Paris.
So this need to find the Paris based on the distance.
Yeah. Of course, you can also install it here, but the set point will be higher. The set point will be higher.
Where the location is the most efficient?
The most efficient, yeah. Yeah.
The first.
Yep. I study a lot. People in Singapore, in US, or Europe, they use the same method. Maybe we don't know how to do it. We don't have time to study in detail. This is what they have done.
For condenser side, so should we apply DST for the pump, condenser water pump?
Yeah, for energy saving, you should do.
But should we apply both the same to the water chiller side and condenser side, or just one of them?
Both of them, it's okay. But the main thing is the chill water side. It's like the most energy efficient chill water pump. Because it's related to the open and lows of the AQ valve. But for condensing side, you install just to make sure you adjust enough the water flow right to the chiller at the the most efficient when you do condensing. And for cooling tower,
right, and the cooling tower. So VFDs for the pump, so can apply together with VFDs for the fan, or just one of them?
Two of them on.
Two of them.
For the fan coil, you need to have it because you want to maintain the chill the condenser water, back to the chiller as the set point. So we should do that way, We have to select the right equipment and with the right design to make the system work. So don't bypass the system. Should have. So the two systems is available in the market. One is conventional, or we can call a hardwired system. This is very simple. I think it's so many years ago. You have this already. So basically, the system comes with the input and the output. So the input is the smoke detector, no address at all, but we group into zone. So depending on the size of the building or the factory, we have like 2 zone, 4 zone, 5, 10, 16, 20, depending on the size of the project. We have with 7 zone. So in one zone, we have the group detector and link to the fire alarm. And then also we have the zone of the metal convoy. We have heat detector, smoke detector, and then when one is in alarm, the panel will tell you, this zone got into alarm, but they don't know exactly, what the location of the fire happened. So this thing we call the conventional. So when this one is send a signal back to the panel, and the panel will send out the output to on the alarm bell or the on and off to notify, the people. So this is a very simple system. And the second system is what the people using nowadays in every building is addressable fire alarm system. So how we call this addressable? Because it's designed, the detector and the module and the boot station or the red flag, they have the unit number assigned to the address to report the alarm and so forth. So in this case, you know exactly when the fire alarm happened, you know exactly the location. That's where the fire happened. So this is addressable. So this addressable detector, every detector can send back to the panel like it's working normally or not, it's in alarm state or stroke or state. In the conventional study, you know whether it's alarm or not, but you don't have so many information in the addressable system. And how about for some urban area, you want to use the addressable panel, but together with the conventional detector, also can do that. We just install, the group of detector together with the zone module, and this zone module have the address, and one of the detector here going to alarm. This one will, report the alarm to the fire alarm panel. So we combine conventional and addressable into one system. So the technical addressable fire alarm system also have two things, one is input and another one is output. So input is you have the group of we can loop. So depend on the size of your building, is a factory, and we can have so many loops, and one loop can support like over 100 detector, depend on manufacturer, but normally like 125 or 159 or 300, 220, 50 or 300 something. So depend. And any detector has to be pressed. So whenever the fire alarm happens, this report to the panel exactly the location. Multiple side Rogers, you can have so many panels and network together. So I see the market like 100 panel or 200 panel can be networked together to form up the big system. And robots, you can have the central rotation. It's like similar to BMS, but this for alarm system. Also have the graphics and display the location of the fire alarm. And you can have the repeater. For example, the fire alarm you install inside the FCC room, the control room. And as the security room, you need to have some kind of repeater. So what happened here, you can see exactly the same in the another room, so we call repeater. This system can also interact with the fireman intercom. So when anything happens, the fireman just use the handshake and plus the handshake to the phone jack and can talk to the operator via the fire alarm system. And you can also have the integrated voice ventilation system. So when anything happens, of course, this one will program to be, like just ring the bell on the job line, and also must announce one, depend on requirement. This one can be separately, or this one can be the part of the fire alarm system. We call it ventilation system. Because when we talk about the fire alarm system, we have to talk about the standard that the manufacturer follow. So the two famous and popular standard in the world, and also now that UL, FM products or EN54. So they have two different sets of standards. So depend on the best tension of the requirement of the owner and the designer, we can have see that preparatory system. Or no visual smoke. So we should install if this requirement is a requirement, we have this one. But nowadays this one is like this harmful for like not environment friendly, So I think most of manufacturing already discontinue on the ion detector. They just have the photoelectric detector and a flame detector. So this kind of smoke, this photoelectric detector can detect this kind of smoke. The ion can detect, and this is the flame. So what kind of automated fire detector? You have a smoke detector. Anyone know the simple one, the heat detector, smoke detector. And another one is light detector. They can use the cable or the beam. So some big area, or the very high ceiling, or some location that you cannot install this. So this is another option. And also another one is air sampling system. Let's draw the air into the boy. You see, use some sampling point here, and inside have the fan, so the air will go into, and the air will go into inside. Of course, inside have like some kind of detector inside, detect whether this air tree is help the smoke inside or not. We want to let you know that this is the most advanced detection technology. Beside the photoelectric detector or heat detector, this is the four advanced detection technology. It's multi-detector and inter-watt detector. Heat exchange, so that's most likely the fire happen. So they make the decision faster. And also they can reduce some kind of nuisance alarm than the fault alarm. Because sometimes the dust or the high wind also cause the problem, the fault alarm. So they said, okay, this the dust. The detector detect already, but no heat at all. So you don't make decision yet. So that's why they say that you utilize two file signature to record faster than bomb rate teledating. Okay. So this is you can install in any place, hotel, resort, office, residential building, so bit more anywhere. The next one is 4-in-1. So this is the 4 major elements of the file is you know, like smoke, right? And where the smoke happen, the CO is inside, and then heat, right? And also like lamp. So this 4 elements inside one detector. So it's even give you more current and design to report the alarm to panel faster. When there's the smoke present in the air, and then you can check the heat, and then also check whether it's the lamp, and also check the CO. So if they change the the sensitivity, so make decision faster and avoid some of the flood. So this application is we should have in the hotel room near the shower, because if you install the smoke detector near the shower, when people take the shower, use shower. So this one can perfect choice for the hotel room, but near the shower, or kitchen also, boiler room, parking area. Next one is vibration protection. So as you see the picture, you can have so many sampling point. So the air will roll into the panel and also keep it reported.
But this is not so common, right?
This one is application where the salary is very high. Like museum, like hotel, atrium, tourist, you have the store. Of course, you cannot install the smoke detector. You also cannot install the beam detector because so many attract. So this is the ideal solution. Because they have the resistor here, right? So normally, if in normal case, the current is coming here. But when it's fire here, and it's bypass, so it increase the current. So it's called the alarm. When detector is both is higher than its alarm set point, a shocks current. So current increase due to the end. Line resistor being bypassed, so it's called the alarm step. And for this one, you have 2 ways to connect to the system. If you want to connect like conventional one, so you just install the monitor module here only. So when anything happen here, like this is like a zone, so the panel will know this zone in trouble in the alarm. But if you want to know exactly location where the fire alarm happened, you need to install this additional point locator. So you know, okay, this is like 500 meters from the panel. Specify.
Is there limitation on the length?
This one is 2,000, right? 2,000 meters. If you 2,000 meters, yeah. But if you want to go as about that, go for 500.
No, because if you talk about 2,000 meters, 2 kilometers, so how do you know exactly at which point is having a fire?
They measure the resistor. So this is you have to order this. This specify, okay, this one go with 500, 1,000, 1,000. So for the longer distance, like 10 kilometers, you have another solution. We use the same methods, but we use fiber optic. This one has the big advantage, like no maintenance, because fiber optic, you have nothing to do with that. No electrical, interference, nothing else. So this one is also good. Typical system configuration like the heat detection zone. In this here heat detection zone, even though one cable only, but you can divide 1,000 zones inside by somewhere. Like you this one one zone, this one one zone, this one one zone, and maybe you have different set point in terms of temperature. For example, this room you set like 50 degrees, it's over that human alarm. This one is 65, this one is 70 or something like that. Also can be done with the fiber optic. So what's the application for that? Can we try? Yeah, you have to push it along the way. Transformer, electrical. So this one, the cooling tower. Yeah, need to do it.
Price
Also wood. But
No,
it's very easy to install, and they have ability, you know, to have interaction with BMS. So they have one PCB, everything, and you go to the distance of like 10,000 meters. So this is good for the tunnel. Yeah, fiber optic. Yeah.
So you're saying that
Something that
Compared to conventional, what's the difference?
conventional one is the also linear detector with wire.
Yeah,
This one is
fiber optic.
the price.
Double.
The panel is expensive. The cable is not expensive.
Oh, that's interesting.
Yeah.
Maybe I invite you separately. I invite you. You come, you take a look because I'm planning to install either heat detector or smoke detector or fire detector in the panel, especially the capacitor bank. Because sometimes capacitor bank, due to harmonics, due to aging, it will rupture. So sometimes when it rupture, it might cause fire. So we need to have something to detect. So this one, can it be installed in a cubicle? Can. So which one is
You see the application.
After training. After the session.
Yeah.
Which one is?
I changed the name because you.
Oh. Oh yeah, you have the electrical appliances. Oh, that's interesting. Okay.
Yeah, this is the right application.
So which one is cheap and good?
I think in your case, this one is good enough.
Shipping no good.
Cheap and good is not reliable.
Shipping no good.
Reasonable, you know. This is a few dollar per meter only.
Okay.
Yeah, but this one is honestly the basic. So this is only applicable for the tunnel.
Okay.
The power plant, you know. Yeah, I install a few power plant for units.
Critical system you should use. Not critical system.
Yeah. A receiver or the detector mirror. You know? So the transistor will transmit the signal to the mirror and it's feedback. So it's something
Cuts.
in the stream. It's called the alarm. But it's how you do in the warehouse because so many obstructions, so many things you cannot do. So this solution. This one is solution. And some material like with water, you know, we should use.
Something like the best system.
Vesta, yeah. Vesta is not the system, the name of the company, but because they like invent the system, you know, the people call Vesta. Yeah.
Because Vesta is very warning.
Yeah. No, but this is the name of the company. Yeah, this is the name of the company. Detector cannot work. But if you change to heat detector and then it's not safety at all.
Yeah, correct.
So this one solution is the Vesta, but too basic. So we keep the inverter, but don't expose to mercury. No solution.
More maintenance.
More regular maintenance will do. Like 3 months. So if we see the smoke, just right. And when it rests, it's automatic ring the bell. And also for fire alarm, you see the MOS, you know, need to have to integrate with BAE, public address and all that.